In this video, we'll be solving a variety of equations from trigonometry and from college algebra. At any time, just go ahead and pause the video and see if you can solve the problem on your own, and then I'll come back and go through the solution. The first couple of problems are from trigonometry. So the first one states, solve for solutions in the interval from 0 degrees to 360 degrees. So once the answer in degrees. Sometimes I want the answer in radians, and the interval will be from 0 to 2 pi. Notice it's closed on the left, open on the right, so 0 can be included. The 360 cannot. Remember, 0 and 360 have a terminal side that coincides. So the first one is quadratic in nature. You'll solve it just like you would solve an equation like, say, 2x squared minus 7x is equal to -3. You could try to factor it, make one side 0. That doesn't work. You can use a quadratic formula. So in this case, what we'll do is we'll try to factor it. So I'll bring the -3 over so I can make the right side 0. So I'll wind up with 2 sine squared x minus 7x plus 3 is equal to 0. And this one does factor. And it factors in 2 sine x minus 1 and sine x minus 3. You can check the multiplication here. Sine of x times 2 sine of x is 2 sine squared x. Then multiply the inner and the other terms. Minus sine x and minus 6 sine x gives me minus 7. And of course I get the -3 times -1 is +3. So at this point we have a product of factors equal to 0. So that means that either one or both factors are equal to 0. So basically I set this equal to 0. This factor can be 0, or this factor can be 0. Solve it for sine of x, and for the first one then I would get sine of x would equal to 1/2. And then for the second factor, solving for sine of x, I would get sine of x equals to 3. Now the range for sine of x has to be between -1 and 1. It can equal to 1, but it cannot be greater than 1. So this equation, sine of x equal to 3, is not possible. So this part has no solution. And sine of x equal to 1/2, we want the angle or angles that have a sine equal to 1/2. If you know your 60-30 reference triangles, you should know that in this case the angle should be 30 degrees. So the sine of 30 degrees is 1/2. And if you have the sine of an angle positive, and it's an acute angle in quadrant 1, there's a corresponding angle in quadrant 2 that also has the same value. So if theta is a solution, and it's acute, then 180 minus theta will also be a solution. So in this case, we have two angles in the interval from 0 to 360 that will work. 30 degrees and 150. So this is your solution. Now if we didn't have a restriction on the interval, they just wanted all solutions, in that case you have an infinite number of solutions, because you can add a multiple of 360 to each of these and you get another answer. For example, 390 degrees will also work. Any multiple at 360 will work. You can also have negative answers, but in this case we're restricted to the interval from 0 to 360, so that's your solution for that equation. Now the next one is not your typical equation. That's why it says use a graphing calculator to solve for solutions in the interval from 0 to 2 pi. So we have 5 sine of x plus x equals to 3. So notice we have a mixture of trig functions, in this case the sine of x, and a basic polynomial, x. So you can't solve this using the traditional approach. So what we're going to do here is we're going to graph this. So basically what we'll do is we'll bring the 3 over, and we'll get 5 sine of x plus x minus 3, and treat this like a function. So you can call this f of x or y1, and you sketch the graph of this. And the zeros of the graph, which you can get from the x-intercepts, are going to be the solutions to this equation. So you go to the calculator and enter the function here. I've already answered here the first one there, 5 sine of x plus x minus 3. So if I hit graph, I get a line, and that's not the graph. Since we're dealing with radians here, we want to go to mode. It's in degrees. So with this type of problem, we want radian. Wants the answer in radians here. So then go back to the graph, and now we get a nice graph. So you can see this one intersects the x-axis at 1 point right there, 2, 3, and it appears to cross over here somewhere, but I think that's going to be past your 2 pi. Let's check it out here. So I'm going to hit second and hit trace key. I'm accessing the calculate key, and I want number 2. So hit that. I want the zeros of this. So actually what I'm getting here is the first component of the x-intercept. So you look at the lower left here, it says it wants a lower bound or left bound. So go up, don't want to get to the point here, and hit enter. Now it wants a right bound. So go past the point, hit enter. Now it wants a guess. You can ignore that and just hit enter. And you can see here that it says 0. X equal to 0.52. I'm going to run that out to 2 places. And notice the y value is 0. So that tells you that when x is equal to that value there, 5.1 and so on, the y value is 0. So this is a 0 of that function. The intercept is at 5, at 0.519, so on, and 0. But the solutions of this equation are given by the first component of the intercept, which is the 0. So in this case, we would say x is equal to 0.52. That's one solution, and that's radians. And then we want another one. So I hit second, trace, again, calculate menu 2. Now I want this other one, the next one. So go move the cursor just slightly to the left of that point where it crosses the x-axis. Hit enter. Once the right bound, so go past the point. Hit enter. Now the guess you can ignore and hit enter again. And it tells me 0 when x is equal to 3.177. So let's round that off to 3.18. So then another 0 or solution in this case is the value 3.18. And these are in radians. Okay, now there's one here also. One more. So go second, again, calculate menu, number 2. And hit enter. We're right to the left of that point. Right bound now. Past it, hit enter. And then for the guess, you can ignore it, hit enter. And we get another 0 at 5.71. Y equals 0, which confirms that it's a 0. The next solution is 5.71. So the zeros are 0.52, 3.18, and 5.71. And those are all in those are the only ones in the interval from 0 to 2 pi. If I continue to go past this, notice it's going to go past. I go up to right at this point, the x value is going to be larger than 2 pi. So that's as far as we can have. Those are the 3 solutions in that interval. Okay, let's go to the next one. Delete this. Now this one's from college algebra, solve for all solutions. We have a polynomial equation, degree 4. So we expect to have at most 4 zeros. Now these could be all real zeros. They could be a mixture of real and non-real or imaginary zeros. So what we want to do is try to find 1 0 by inspection, and maybe, or actually we can apply 2 so we can able to factor it down some. So one of the things I'll use here is the rational zeros theorem that tells me if the lead coefficient here is a 1, if this has any rational zeros, there'll be factors of -8. So what are the factors of -8? Well, you have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. So you try any of those and see which ones work. Usually you want to start with the smaller ones. So I'm going to start with 1, and I'm going to use synthetic division. So I'm going to put a 1 here, and in this first row that I have here, I have the coefficients of this polynomial on the left. X to the 4th, coefficient of 1. X to the 3rd has a coefficient of 1. X squared, coefficient of 2. X has a coefficient of 4, and then the constant is -8. Now, if there's a term missing, these have to be in descending power. So if it doesn't have an x cubed, then here instead of a 1, we put a 0. Otherwise, you might not get the correct solution. So I'm using synthetic division. So when I put a 1 here and do this operation, I'm actually dividing this polynomial by x minus 1. And that's, of course, reducing it from a 4th degree to a 3rd degree. So we go 1 times 1, and then we bring it over to the next column. We'll put it here. Then 1 and 1 is 2. And then we go 1 times 2 is 2. 2 and 2 is 4. And we go again. 1 times 4 is 4. 4 and 4 is 8. 1 times 8 is 8. Minus 8 and 8 is 0. Now, if this last number in this row here does not come out to a 0, then the 1 is not a 0 of the polynomial. So you would try, say, -1. Well, in this case, 1 works. -1, if I go through the procedure, is not a 0. Then I would go to the next one. I would try 2. I would bring this down here. 1. I put a 2 here. And I go through the same thing. 2 times 1 is 2. And I do the same thing I did in the first series of steps. 2 doesn't work, though. I don't get a 0. So then I would try a -2. I go -2 times 1. -2. And then -2 times, 2 and -2 will give me 0. And then -2 times 0 is 0. 4 and 0 is 4. -2 times a 4 is a -8. 8 and -8 is 0. So, just with those steps, I know that the solution to this equation, one solution is 1. The second solution is -2. So I've got 2 real solutions. And see, every time I put a number here in this little square here, I'm dividing by x minus that number. In this case, the first one I'm dividing by x minus 1. The second one I'm dividing by x plus 2. So every time I do a division, it reduces it from a 4th degree to a 3rd degree and then to a 2nd degree. So this is actually 2nd degree now. So the 1, the 0, and the 4 are the coefficients of a 2nd degree polynomial. So it'd be x squared, x, and then a constant. So this would say, okay, I have an x squared, 0x, so I'll leave that out, and then plus 4. So the 2 remaining solutions are going to be the numbers that make this x squared plus 4 equal to 0. So basically I solve this equation. Basic quadratic, add -4 to both sides, and take the square root, plus or minus. So I got x then will equal 2 plus or minus the square root of -4. Well, the square root of -1 gives you the I, the imaginary unit for complex numbers or imaginary numbers, and the square root of 4 is 2. So this gives me then complex solutions plus or minus 2y. This is plus or minus 2i. And this is your solution. Fourth degree polynomial equation, so we expect at most 4 zeros. In this case, we have 2 real zeros, 1 and negative 2, and 2 complex zeros, 2i and minus 2i. I'm going to end this particular video here. I do have some other examples, but I don't want the video to get too long. So I'll do a part 2 later on, maybe a little bit more complex problems. Still some in algebra and a few more in trigonometry. So more to come on equations from algebra and trigonometry. Thanks for watching. We'll see you next time.